Welcome back to the channel. Today, we are tackling a massive algebraic fraction that looks like it would crash a standard calculator. But if we use a few clever algebra tricks, we can solve this cleanly by hand. Let's look at the problem. We need to simplify a large fraction. In the numerator, we have 2 to the power of 101 plus 8. In the denominator, we have 16 to the power of 13 plus 4 to the power of 14 plus 8. Right away, we can see that all these bases, 2, 4, 8, and 16, are powers of 2. Our first logical step is to rewrite everything using a base of 2. In the numerator, our 8 becomes 2 to the power of 3. In the denominator, our 16 is 2 to the power of 4. If we raise that to the 13th power, we multiply the exponents to get 2 to the power of 52. Next, our 4 is 2 squared. Raised to the 14th power, that becomes 2 to the power of 28. And finally, that 8 at the end becomes 2 to the power of 3. So, our newly updated fraction looks like this. On top, 2 to the power of 101 plus 2 to the power of 3. On the bottom, 2 to the power of 52 plus 2 to the power of 28 plus 2 to the power of 3. Notice that every single term has at least a 2 to the power of 3 hiding inside it. Let's factor that out from both the top and the bottom. When we pull 2 to the power of 3 out of the numerator, we are left with 2 to the power of 98 plus 1. When we pull it out of the denominator, we are left with 2 to the power of 49 plus 2 to the power of 25 plus 1. Because we factored 2 to the power of 3 out of both the top and the bottom, they cancel each other out perfectly. We are making great progress, but those exponents are still huge. Let's use substitution to make this visually simpler. Let's set the variable x equal to 2 to the power of 25. If x is 2 to the power of 25, then x squared is 2 to the power of 50, and x to the 4th power is 2 to the power of 100. Now, look at our fraction. We have 2 to the power of 98. We can rewrite that as 2 to the power of 100 divided by 2 squared, which is exactly x to the 4th power divided by 4. We can do the exact same trick for 2 to the power of 49. That is 2 to the power of 50 divided by 2 to the 1st power, which becomes x squared divided by 2. Let's plug our x terms back into the fraction. Our numerator is now x to the 4th power over 4 plus 1. Our denominator is x squared over 2 plus x plus 1. To get rid of those annoying mini fractions, let's multiply the entire top and bottom by 4. Our new numerator becomes x to the 4th power plus 4. Our new denominator becomes 2x squared plus 4x plus 4. Let's pull a 2 out of that denominator to make it 2 times the group x squared plus 2x plus 2. Now, let's look at the numerator again. X to the 4th power plus 4. This is a classic setup for the Sophie Germain identity. We are going to intentionally add 4x squared and then immediately subtract 4x squared. By doing this, the first 3 terms, x to the 4th plus 4 plus 4x squared, fold perfectly into a perfect square. It becomes the quantity x squared plus 2 all squared. And 4x squared is 2x whole squared. Now we have a beautiful difference of squares. The quantity x squared plus 2 squared minus the quantity 2x squared.
And it's all divided by 2 times the group x squared plus 2x plus 2. Using the difference of squares rule, the numerator splits into 2 factors. The first is x squared minus 2x plus 2. The second is x squared plus 2x plus 2. And the denominator is 2 times the group x squared plus 2x plus 2. Look at that! We have an exact match. That entire second group in our numerator cancels out perfectly with the group in our denominator. All we are left with is x squared minus 2x plus 2, all divided by 2. We are at the finish line. Let's plug our actual numbers back in. Remember, x equals 2 to the power of 25. So x squared is 2 to the power of 50. 2 times x is 2 to the power of 26. Our expression is now 2 to the power of 50 minus 2 to the power of 26 plus 2, all divided by 2. Finally, divide every single term by that 2 on the bottom. We get 2 to the power of 49 minus 2 to the power of 25 plus 1. And that is our exact simplified answer. We completely dismantled this massive fraction using clean, logical algebraic steps. Let me know in the comments if you spotted the Sophie Germain identity before I did. I will catch you guys in the next video.